Good morning. So today we'll start with the next part of the signal flow graph. Today in both the classes, I'll complete the signal flow graph problems. So uh, everybody just copy down this problem statement. Everybody just copy down this problem statement. So we'll go with the signal flow graph problem. Uh, hope hope I'm audible to everybody and the screen is visible to everybody. Yes, anybody can just. Yes,
Yes, sir.
Yes, sir. Yes,
okay.
sir.
Okay. So what you do is you just copy down this problem. Uh, we'll just go slowly because it is a span of almost after 15 days we are joining the class. So once again, I'll refresh the concept of signal flow graph. There are 2 to 3 problems we'll be doing. So today we'll be trying to complete the signal flow graph problems. You just copy down this. And important while copying this, make sure that you copy this the flow of the signal correctly. So the initial point is R of S and Y of S. So the input node is R of S and the output node or the terminating node is Y of S. And once you're done with this, you can just put a message that we are done so that we'll start solving the problems. Yes, hope everybody is taking down this problem. Yes. Is there any confusion with this? Those who are joined late, today we are this going ahead with the problems on signal flow graph. Everybody just take down this problem. And one more thing, what you can do is you can name these nodes in clockwise direction or anti-clockwise, whichever is convenient to you. I prefer to do it in clockwise. I'll consider this as node number 1, this as node number 2, this as node number 3, this as 4, this as 5, this as 6, this as 7, and this as 8. So there are totally 8 number of nodes which are there. So starting from R of S, this is node 2, 3, 4, 5, 6, 7, and 8. So these are totally 8 number of nodes. So the signal is going to start. So once this is done, first and the foremost thing what we are going to do is we are going to find the number of paths. So if you just observe here, there are 2 number of forward paths. One is this. You can see that is a red color starting from 1, 2, 3, 4, and 5, or G1, G2, G3, and G4. So this is the path gain. So P1 or the forward path is given by G1, G2, G3, and G4. Then the second one is G5, G6, G7, and G8. So there are totally 2 number of forward paths. Hope this point is clear. Any doubts are there? Do you have any doubts? Yes, yeah, please either message or let me know. Is this point clear? Okay, then.
Clear, sir. Clear.
Okay, then next what we are going to do is we are going to find the total number of loops. So if you just see the loops, there are 4 number of loops. So which are those loops? Loop is this, that is G1 H2. Inside we have written L1 here. G1 H2. Second loop is L2, that is G3 H3. Then the third loop is G6 H6, and the fourth loop is G7 H7. So these are the four number of loops which are present. So then also we are going to see, consider the two non-touching loops. So in case of here, remember, whenever the problem is asked to solve the signal flow graph using the Mason's gain formula, the first step what you are going to do is, whatever the sketch is given in the question paper, you'll have to redraw this and go on naming the nodes as and the number. Then try to go with the forward paths. First, once the forward path is done, you'll have to find how many number of loops are there, single loops. Then second one is find the two non-touching loops. So if I see here, which are the options? L1, L3, L1, L4 are the two non-touching loops pair. So this is here L1, L3 and L1, L4. Why? Because if you see here, these two nodes are not nowhere connected or nowhere joining this nodes. So loop 1 is independent of L3 and L4. So if I take two loops in a pair, so L1, L3 is one option, L1, L4 is another option. Similarly, L2, L3 is another option, L2, L4 is another option. So you can just see here, there are totally four number of loops if I take two non-touching loops in a pair, that is L1, L3, L1, L4, L2, L3, L2, L4. So this is the second. Then next step is find the loops when I take in step of 3. So if we consider step of 3, we do not have. Why? Because either of totally there are 4 loops and 2 loops are touching one another. So I cannot have a combination of 3 loops which are touching each other. So that is not possible. So this is the end of the initial data whatever we can obtain. So after this, we'll have to go with the finding the delta. What is delta? Delta is 1 minus. Delta is 1 minus. As I've told, since it is a odd number, that is all the loop gains of loops. So if it is a single loop, so it is L1, L2, L3, and L4. As it is an odd number, we have negative sign. Plus, because we are taking two loop in a because two non-touching loops when you are taking into consideration, since it is 2, we have positive sign. So whatever loop gains are there for single loop, we have added here. Whatever loop gains are of two non-touching loops, have put up here. So this becomes your delta. So delta is determinant is 1 minus loop gains of a single loop plus loop gains of two non-touching loops taken as a pair. So whatever the L1, L3 values were there, all you have notated down here. So this becomes your delta. Once the delta is done, next what we are going to do is we are going to write the delta 1 for the forward path. Because which one is the forward path? Here the forward path is the above path. The path which was there, that was G2, G3, G4 and G5 was G1, G2, G3, G4. G1, G2, G3, G4 is the forward path. To that, the eliminated forward path, so it will be 1 minus L3 plus L4. Why? Because these two loops are not touching. So what is the delta 1? Delta 1 suggests that it is 1 minus the loop gain of those loops which are not touching that forward path. Now if you just observe here, this is the forward path. I'll just show you one more image so they'll understand. Here, if you just see loop 1, which was the loop 1 or the forward path G1, G2, G3 and G4. If you just see this, here L3 and L4 are not touching. So it will be 1 minus L3 plus L4 because eliminate forward path number. In case of this, what has happened is here that is L3 and L4 are not touching. So we are taking that loop gain. So delta 1 is nothing but 1 minus L3 plus L4. Similarly for forward path number 2, which is forward path number 2, this is the forward path number 2, that is G5, G6, G7 and G8. In that case, L1 and L2 are not touching, so delta 2 will be 1 minus L1 plus L2. Now, why this is because we have the formula, because remember how many number of forward paths are there, that many number of we are going to get this P1 delta 1 plus P2 delta 3. If there was one more forward path, we would have gone P2 delta 4 or P3 delta 3, so on. So if you just observe, P1 value is known because we know what is the forward path. Delta 1 we have found out. Similarly, P2 we know. Delta 2 we have found out, and also we have found out the delta. So directly you can substitute the value and finally get this answer. Okay. Do you have any confusion with respect to this? Anybody? Anybody is having any confusion? How to find delta 1 and delta 2? In finding delta 1 and delta 2, is there anybody is having any confusion? Yes. In case if you have doubt, let me know. I'll clarify. If yes, do you have any doubt? Please respond.
No, sir. No, sir.
Okay, okay. Okay. Why there is a very thin attendance today? Only 35 students have attended. You are also not in a position to let all. But is there any other placement or any other activity associated? Okay.
No, sir. Today there is nothing.
Okay, okay, no problem. Okay.
Yes, sir.
So,
TCS exam is there, sir.
exam is there. Okay, okay. I just take down this image. This is another problem. Just take down this. Just take down this problem. This is problem number 3. Okay. Hope you have noted down this problem. Now, if you just see here.
1 minute.
Okay, no, you can note it down. In the meantime, I'll just a minute. Somebody has put some kind of message. Okay. Now here one matter. Now, if you just observe here, you take your time to note it down. But in the meantime, I'll explain it once again. See here, there are how many number of nodes? Again, we'll go in clockwise. So this is the input node, that is R of S, and C of S is the output node. So I consider this as node number 2, this is node number 3, this is node number 4, this is node number 5, this is node number 6, this is node number 7, and this is node number 8. So totally there are 8 number of nodes. Why this is very important? Because while finding this forward path, sometimes people or student get confused. In order to see that doubt is not there, so better you put the numbering for the nodes. Now once this is done, you can just observe the mean. So once I think hope everybody has done with the problem, so we'll just find what is the first path, that is forward path. So if you just see, there is one forward path as of now. We can see that is R of S to C of S, that is a very straight line, that is G1, G2, G3, G4, G5. See here, if you can skip that S, if you want, you can skip that S, that is G1 of S. Even if you do not write G1 of S, it is okay. You write G1, G2, G3, G4, G5, V1, V2, V3, H1, H2. So that can be written. Now, if you just here, there is only one forward path which is put in the red color. If you just see here, red color notation is there, that is G1, G2, G3, G4, G5. So this is only the one forward path which is present. Then how many number of loops are there? Now presently, if you just see here, there is one loop, that is G1 into H1. So just see here. So how many number of loops are there? Are totally 4 number of loops. Which are those? I'll just explain here. See, this one is of one loop, that is G1H1, G1H1. Then G4H2 is another loop. G4H2 is another loop, that is L2. Then what is the L3? L3 is G7H4, G7H4, G7H4. This one is a third loop. Then there is a one more fourth loop, which is the biggest loop, that is G2, G3, G4, G5, G6, G7, G8. So this entire thing, that is this here, from here to here. Then once again, I'll just show you in the sketch so you can understand. Pen. See this part. So here there is one more loop. So we can see here G2, G3, G4, G5, G6, G7, G8. So this semicircle is one more loop. Just a second. To erase that, you'll have to slide escape. Okay. So there are 4 loops. Now, next one is, what is next part? Take 2 loops which are not touching one another. So we can have the combination of L1, L2, L1, L3, then L2, L3. So this only the 3 combination. Why? Because L4, in L4, L1, L2 and L3 are always lying on L4. So I cannot take L4. So in this condition, you can see L1, L2 and L3 are the 3 loops are there. So I can go in the pair of L1, L2, L1, L3, L2, L3. You can just see here. So this is how it is, combination L1, L2, L1, L3 and L2, L3. That is 2 non-touching loops taken 2 at a time. Then non-touching loops taken 3 at a time. Which are those? We can take L1, L2 and L3. Because why? Because L1, L2 and L3, they do not lie on the same nodes. So I can take that combination also. You can just here non-touching loops taken 3 at a time. So L1, L2, L3. That is the reason why here, if you see that the length of the values are going on increasing. So that is the reason why I said you do not take that yes into bracket. Even you can skip yes, you can write G2H1, G4H2, G7H4. Okay, so I'll just go back. In the meantime, you can just copy down this. Forward path is G1, G2, G3, G4, G5. This is your forward path. Second is, there are 4 feedback loops, L1, L2, L3 and L4. Just note down this also. That is G1H1, G4H2, G7H4, then G2, G3, G4, G5, G6, G7, G8. This is the fourth loop. Then next part is non-touching loops taken 2 at a time. Which are those? L1, L2 option is one, L1, L3 is another option, and then L2, L3 is another option. So there are three such possibilities when non-touching loops taken 2 at a time is done. Then we have 3 options.
Hello, sir.
Yes, yes, tell me. Any doubts? Yes, tell me.
So L4 and L2 can be a pair, sir.
No. Why? Because because L4 and L2, they are again like, see here, in that term, I'll tell you. See here, if you just observe here, I'll go with L1 and L2. L1 and L2. See, same terms should not appear in the answer. If I take L2 and L4, see here, L2 and L4, G4 is up. G4 will be there in case of L2, and G2, G3, G4, G5, G6, G7 and G8. So same term will never appear when we take a pair. Got it? You just observe here.
Okay.
Understood?
Yes,
No?
sir.
So it should not be a square.
Yes, sir.
The square should not come. If the square comes, no, means G4 square will happen, no, because G4 into G4. So then it is wrong. So that is what is how to verify whether my answer is correct or no. See that same terms will never appear after multiplication. If they appear, means that option, whatever you have chosen, is wrong. Just observe that. That is one of the important cross check. Then once again,
Yes, sir.
3 non-touching loops taken 3 at a time. L1, L2 and L3. L1, L2 and L3 is the third option. So now as we have seen, there is only one P1. So what we'll do is we'll go with what is delta 1? Delta 1 will be 1 minus loops of all the loops, that is a loop gain of all the loops, single loops, plus non-touching loops taken 2 at a time, minus loop gains of loops 3 at a time. So it will be what? L1 plus L2 plus L3 plus L4. Sorry, I'll just tell you how it will be. It will be 1 minus into bracket L1, L2, L3, L4 bracket complete plus L1, L2 plus L2, L3 plus L1, L4, sorry, L1, L3 minus L1, L2, L3. So that is what is written here. If you just observe here, 1 minus L1, L2, L3, L4. This is then plus L1, L2, L2, L3, L1, L3. This is there minus L1, L2, L3. So this is what is written in the delta. Now, so as I know, there is only one forward path. So what we can do is we will find that loop which is not touching that forward path. Now, if you just observe, L1 and L2 are touching this forward path, L3 is not touching the forward path. So delta 1 will be 1 minus the loop gain of L3. That is what? G7H4. G7H4 is written here. So final answer will be C by R is equal to P1 delta 1 divided by delta. P1 that will be delta, which is equal to P1 value is known. What is the P1 value? P1 value is G1, G2, G3, G4, G5 into 1 minus G7H4 upon this. That is delta. Is it clear? Any doubts? Any doubts are there? Do you have any doubts? Anybody is having any doubt? Because this, whatever problems are solving, remember, this will come for in exam for 15 marks. Guarantee questions. These are the guarantee question which will be there in your exam. So don't get confused. If you have any doubts, let me know. Is it clear? Any doubts are there?
No, sir. No doubts.
Okay. Okay.
No doubts.
Okay. Now, now just take down this problem, everybody. Take down this problem and mark this problem important. Whatever problems, this is example number 4. You mark this problem very important because it is a very bigger, means a lengthier problem. Now taken a lengthier problem has been taken here. You can just mark this as very important. Okay, just this, so you can see here x1, x2, x3, x4, 5, x6, x7, and x8. So these are the nodes which are there. And important is, as I told once again, make sure that you write all the arrows correctly. So there will not be any confusion. So you can see here, depending upon the arrows only, you'll come to know that how many number of paths are there. You can from here I can without this you can see that there are three number of forward paths. That is, one is x1 to x2, x2 to x3, x3 to x4, 4 to 5, 5 to 6, 6 to 7, and 7 to 8. That is a straight line which will be joining from x1 to x8. That is the first forward path. Then the second forward path is x1 to x2, then from 2 to 4 from this route. I'll just show you the images so that you'll understand. So see here, now you can see that blue color line or slightly grayish color line is your first forward path. That is A32, 43, 54, 65, 76 is your first forward path. And the second forward path is this blue color line. That is from, I'll just show you once again so that you'll understand this line. So this is the thing, that is from 1 to 2, that is from x2 it will directly go to x7 and x8 like a boat shape, that is like a bathtub curve shape. So this is how from 1 to 2, from 2 to directly it will go to x7 and x8. This is one. There is one more from 1 to 2 it will go like this, then this. Okay, I'm doing it with this mouse pad, laptop pad. So that is the reason why it is not so clear. So just understand this. Okay, from x1 to x2, from 2 to x4, then x5, x6, x7, and x8. So this is there are the three forward paths. So that is what is shown here. So that is what is shown in the black color. Shown in the black color. So we'll just so we'll just show this is first forward path, this is second forward path, and this one is the third forward path. So all the three forward paths are mentioned here. So one is the straight line, then one is the second which will be from here, that is blue color, and one is the black color which is at the top. So once these forward paths are done, so you can modify the Mason's gain formula, that is C by R is equal to P1 delta 1, P2 delta 2 plus P2 delta 3 divided by delta. So here, if you write this also, you'll be getting around 20% of the marks. Remember, when you are clear with your forward pass and write a modified Mason's gain formula, you'll be getting around 20% of the marks of the problem. So make sure that once the forward path is done, you write that equation. Then once this is done, what we are supposed to do is find the number of loops. Which are those that we are going to find it here. So which are those loops? I'll just show you here. Now just observe here. One is A1, that is A2 23, that is A3. This is one forward path. This is one loop. Sorry, this is another loop. This is the third loop. This one is the fourth loop. This one is the fifth loop. 1 minute. I'll just show you. 1 minute. A second. This type of this problem we have done it. I'll just show you that. So that this same problem what we had done, but we had not taken that as to find the Mason's gain formula. For the earlier problem we have just done it. I'll go back to that so that you'll understand that problem clearly. It is the same problem. Here the same problem. The same problem is taken here. The same problem is taken here. Only what here forward paths I had told. This is the forward path. This is one forward path. This is second forward path. This is the third forward path. And how many number of loops are there? This is the first loop. This one is your second loop. This one is the third loop. This is the fourth loop, fifth loop, sixth loop. So if you just see how many loops are there, 1, 2, 3, 4, 5, and 6. There are 6 loops. Then there is one more loop, that is seventh loop, which is this. That is, how is the loop starting from? It's starting from x2. It goes from x4. So this is your seventh loop. This is the eighth loop. That is, just observe here carefully. Carefully, that is x5 to x6. x5 to x6. Here, this is x5 to x6. Then x6 to x7. From x7 to x5. This is the one more loop. That is from the top sector. Then there is one more loop, that is this, that is from 2 to 3, 3 to 4, sorry, 1 minute, it is not like that, it is from like this. So from x2 to x7, from x2 to x7, from x7 to x5, x5 to x4, x4 to x3, and x3 to x2. This is one more loop. And there is one more loop like this. It is x2 to x7, x7 to x6, x2 x5, x4, x3, and x2. So totally, I'll just go back there to the problem so that I'll explain there only. Since I have taken that problem here now, if totally, so there are 10 number of loops. So what you do is you just note down these values, and for this you can note down that the previous problem whatever is solved, that is a reference for your this. So the PPT is already, means that problem is already solved there. We have discussed that, but only we are finding the Mason's formula by this. So just everybody just copy down these values. That is L1, L2, L3, L4, L5, L6, L7, L8, L9, and L10. So once again, I can explain here. So I'll just, for your benefit, what I'll do is I'll just show you everybody, which is this. So this is one loop. Then this one is another loop. This one is your third loop. 65, 56. This one is the third loop. And 70, 76, 67. This one is the fourth loop. Then 76, 67. 76, 67 is done. Then 76, 67, 7. Okay, this is done. Then this is L5. Once here, 1, 2, 3, 4, and 5 is done. Then this one is your sixth loop. Then seventh loop is this A42, A34, A23, A42, A42. This one is the seventh loop. And which one is the eighth loop? 65, 76, 67. 65, 76, 67 means this is the loop. So this loop. This entire loop is one more loop. That is eighth loop. Then what is the ninth loop? 72. This is this. It will start from here. It will go from here. And then it will be like this. This is there. Then last one is this. It will start from 72. This bottom loops. So I hope this is clear. Any doubts are there here? Do you have any doubts with respect to this number of loops, identifying the number of loops here? Any doubts?
Sir.
Hey, tell me. Yes.
Excuse me,
tell me.
Yes, sir.
Tell me.
So at a given point of time, we can consider only one loop, no, sir? One feedback loop.
Only
so how
one
can we
feedback
consider
loop.
so many loops at one time, sir? So because in earlier problem we did the same thing.
No. Earlier problem also, we here only we're finding number of loops. Single loops we're finding. An earlier
Yes, sir,
problem.
but then from 8A7 to you're taking all the feedback loops, no, sir?
No. Here, if you just see here, we have not done with the another thing. So first and the foremost thing is, in given the single flow graph, first is to find the forward path. So first forward path we have already found. There are 3 forward paths which are there. Then what we have to find is, we'll have to find how many number of single loops are available. Single loops are available. So if you just see here, there are totally number of 10 single loops are available. 10 single loops are available. Then we will go to that option where we are taking 2 non-touching loops, taken 2 at a time. Are you getting it? Any confusion?
Sir, see here, say L10, sir, in case of L10.
Hi, L10, tell me.
So we have considered A72 first. And then A67, A56, A45, A34. So these are 1, 2, 3, 4, 5 loops, no, sir?
No.
Feedback loops and one
5 feedback loops. No. 5 feedback loops. When it will happen is, in that condition, you are taking that above line. You just imagine that above line is missing. Getting it? I'll just show you this image so that
yes,
I'll just show you 1 minute. So that I'll clarify that 1 minute. Show you that so that you'll understand. Just show you that image. So if you just see here in slide number 20, here, this red color, whatever part you are able to see, just here. Now see here, in this red color path, what is going to happen is, this is one loop now. where from x2 to x7 it is going, from x7 to this is only one loop, because it has started from this. If I take this forward path, this if I'm taking this line, then that becomes a multiple loop, but there is no forward, there is no line, no. If you just here, it is like see, it is this shape. So we are not traversing any other point more than once. So this is one loop. Similarly, this is one more loop where just here from x2 to x7, then 7 to 6, 6 to 5, 5 to 4, 4 to 3, and 3 to 1. In this case, again, we have not traversed a single point more than once. So this is one more loop. I hope I'm clear. Have understood this?
Yes, 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 sir.
Understood. No, means in this case, we have not traversed that path more than once. In this case also, we have not traversed that path more than once. If you just here in this, I think this was L10 and this was previous was L9. In this, I think this is L9. In this L9, x2 to x3, sorry, x2 to x7, 7 to 5, 5 to 4, 4 to 3, 3 to 1. So that is the reason why I want you to put the numberings onto these nodes. When you put the numbering onto nodes, you'll come to know that whether whatever loops I'm taking, is it correct or no. If you just here, if I consider this as number 2, this as 7. So 2 to 7, 7 to 5, 5 to 4, 4 to 3, 3 to 1. Sorry, 3 to 2. So this is one loop, that is L9. And this is L10. L10 is 2 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 2. So this is one more loop. So with this, we have not gone to those loops where that line is passing that loop more than once. Is it clear? What I'll do is I'll just stop here. You can take a 15 minutes break, then I'll complete another part of this problem.
Okay.
Okay. Okay, welcome back. So we'll start with the next part. Okay, hope I'm audible to everybody. Shall we start?
Yes, sir. Yes, sir.
Okay. Now, if you just see here, what we have done is the first part of the problem was to find number of forward paths that we have done. That is, there are 3 forward paths. That is L1, P1, P2, P3. And similarly, there are around 10 loops. So these are the 3 forward paths, and there are 10 single loops. Now, if you just see, we'll have to go with the non-touching loops taken 2 at a time. 2 at a time. If you just see, I'll go with L1, L1, L3, L1, L4, then L1, L5. That is what is here. L1, L3, L1, L4, L1, L5, L1, L6, L1, L8. Now, how is that done? I'll just tell you here. If you just observe here, L1, what is L1? That is A32, A23. This is one loop. Similarly, then what is L3? L3 is 54, 45. Now, if you just see here, this, what I'll do for your clarification, I'll just do it one thing so that you'll understand. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this one is 8. Now, if you just observe here, so if you just see here, L1, what is L1? It is 2 to 3, 3 to 2. That is 1. Then L3, what is L3? That is 4 to 5 and 5 to 4. So if you just see here, this part and this one are not touching. So if this is L1, this is L1, then this one is L2, this one is L3, this one is L4, this one is L5. Now, if you just see here, L1, this is L1, L1, this is L1 and L3. L1 and L3 are not touching. Why? Because they do not have common loops. So L1, L3 is one combination. Then L1, L4, L1, L5. Then which is an L6? L6 is this. L6 is this. That is what is here. Here that is 5 to there is 5 to 6, then 6 to 7 and 7 to 5. So this is our L8, then L8. So if you just see here L1, L2, L3, L4, L5, L6. So and even L8 is also there. So and this one is L6. This is L7. Whatever done. So if you just see here, so taking 2 loops at a time, we can find how many 1, 2, 3, 4, and 5 for L1. Similarly for L2, if we just see with L2, L4, L5, this is then L6 and L8. Again, L6 and L8 are not touching. Similarly, if I go to L3, L5 is not touching and L6 is also not touching. Then if I go for L4, L6 is not touching and L8. Which one is L8? This is L8. Which one is L8? We'll just see one so they'll understand. L8 is 65, 76, 65, 76, 57, 67. Okay, correct.
Sir, excuse me.
Tell me.
Sir, when we are taking combination, we should check which are not touching, no, sir?
Which are not touching.
Okay, sir.
So take those non-touching loops which are not touching. So if you just here once again, and here one you need not take again L3, L1 because it is already taken into consideration here. If you just observe here, L1, L3 or L3, L1 already it is taken into consideration. Need not write it once again because it is like A into B or B into A. That is finally is going to remain same. So there you can skip it. Understood with this? So need not write multiple things. Then again L4, L6 is there. Then L4, L7. Then L5, L7, L8. So if you just observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 combinations are possible for
So which is L6, sir?
L6. I'll just tell you. L6 is this A77, this self loop.
Okay, okay, okay.
Then L7 is this 42, 34. That is this 42, 34, 20. Here this 42, 34. Here this 42, 34, 23. This part. This one is your L7. L8 is 65, 65, 76, 57. 65, 76, 57. This one is or 67. This one is our L8. So if you just observe, so there are so many options are there. So totally there are 13 two non-touching loops. Similarly, here what you can do is again you can go for somehow that slide is missed. Just see. Again here what you can do is go for 3 non-touching loops. 3 non-touching loops can be done. 1 minute. Just a second. Okay, 1 minute. Okay, what has happened is that somehow that slide is deleted. Okay, problem is partially is taken into consideration. Okay, I'll recorrect this and I'll put it in the solution. I'll recorrect this and put it in the solution. So again, here what is there? 3 non-touching loops you'll have to take. So this one is again you can go with the combination L1, L2, L3. So here I'll just stop this problem because if you just see here, I've solved it partially. I'll solve this problem and I'll give the solution in the next class for this problem. Got it? So here you can just stop it from here only. Then I'll solve it in the next class. This problem. Somehow that slide I had done it. Somehow it is deleted or missed. Okay. So with this, the problems on Mason's gain formula are done. There is one more type of problem which is usually asked in the exam. There is one more type of problem which is usually asked in exam. What is that? Is given a block diagram. Given a block diagram, you'll have to convert that block diagram into signal flow graph. That is one more type of the problem. You can just take down this block diagram. Everybody, just take down this block diagram. Just take down this block diagram. Given a complex block diagram can be solved to the a signal flow graph, and that can be solved. So just see here, this is one signal block diagram, and how to go about this, that is explained here. Now, hope this thing is visible to you all, and any doubts are there here? Just observe here. This is an x1. This is minus x2. This is minus x. This is x2. This one is x3. This is then. So here, if you just observe, this is minus. That is for minus sign is for h3. Minus sign is for h2. Then minus sign is for h1. So minus h1, minus h2, minus h3. Then E of s, x1, x2, x3, C of s. So this is how it is there. Hope this is visible and clear. Any doubts? Just take down this
What
problem.
is x1, x2, x3, sir?
X1, X2, X3 are nothing but the gain which are going from one point to another, or those are, I can consider that as the nodes. In this condition, those are nothing but the nodes, or the point of nodes. If you just see here, X1, X2 are nothing but the nodes. So E of S is one node here, X1 is the one node here, X2 is a node here, X3 is a node here, then C of S. So that is what we are going to do. So the input is coming from R of S, then it will come to E of S, and then X1, X2, X3. So if we just consider that from E of S to X1 of S, it is connected by a line which is having a gain of G1. From X2 to X1 to X2, there is a line which is having a gain of G2. Then from X2 to X3, there is a line which is having a gain of G3. And similarly, G4 is the gain between X3 to C of S. And from C of S to X2, there is a feedback which is having minus H1. Then from X3 to X1, that is, there is a minus H2 as a feedback. And from C of S to E of S, that is minus H3. This is minus H3. So this is one problem. So what is asked is, given a block diagram, convert it to signal flow graph and find the solution. That is how the problem is asked. So this is also one type of the problem. Most of the time has never been asked, but even then I thought in most of the books these problems are solved. So I thought this will have one problem, so that you will be aware of how converting a block diagram into signal flow graph and then solving. If you can directly solve, no problem, but they specifically say that from block diagram to signal flow graph conversion, that has to be done. In this previous slide here, the method has been told. I thought if I go on telling the method, you may not understand. So if I solve a problem, then you'll understand it. So given a signal flow graph, what has to be done is, given a block diagram, wherever the points are there, that is like a summing point and the takeoff point, there you go on naming the nodes. If it is not there, what you can do is you just use your terminology to name. So I can say that is X1, X2, X3, and E of S, C of S, and R of S is already, they'll be given in the problem. So you just convert a given block diagram into a signal flow graph as shown in the below. Now, next what we are going to do is, we are going to go with the method. What is that? Again, the formula is simple. First, find how many number of forward paths are there. There is only one forward path, that is R of S to E of S, E of S to X1, X2, then X3, then C of S. So there is one. So 1 minute. There is one. There is one thing. It is not connected here. So inside it is. So this, if you just see here, what we do is we have one forward path, and with one forward path, find how many number of loops are there. Now you can just see there is one loop which is that loop. The loop is this. That is, one is G2, G3, H2. G2, G3 is one loop. Then G1, G2, G3, G4, H3. This is one more loop. Then G3, G4, H1. This is the one more loop. So there are 3 loops. So 3 loops are there, and all loops are touching one another. So there is no possibility of taking non-touching loops, taking 2 at a time. So L1, L2, L3 all have negative sign, so that negative sign is coming outside, so it is positive. Forward path is there, and since all the loops are there on the forward path, delta 1 is this. Therefore, the formula is P1 delta 1 divided by delta. Then what is delta? Delta is there 1 minus loop gains of G1, G2, G3, H3, G2, G3 minus H2, that is minus again taken. Then G3, G4 minus again is brought here. So this is 1 plus this. So that is what is the problem. Hope you understood this problem. Any doubts? Is it clear?
Yes, sir. Yes,
okay.
Sir.
With this, the problem on signal flow graph and this is done. With this, whatever the problem, that fourth problem was there, that solution, I'll just put it and I'll explain it in the next class. So there is one more problem in a similar range. You can just take down this problem also for your this. Just take down, determine the transfer function for the block diagram shown by the signal flow graph technique. Means what? This is usually the problem is asked here. Determine the transfer function C of S divided by R of S for the block diagram below by signal flow graph technique. Means what? Given is a block diagram, you have to solve that by the signal flow graph. So given this problem, you have to convert that into a signal flow graph and then you have to solve it. Just take down this. No, if you just observe here carefully, one thing here, from here there is one signal which is going. From the same point, there is one more signal which is going to this. So that is what is shown here. So from this node, so one signal that is minus h1 is going here. Then from here there is one h signal which is going here positive, and here there is a negative sign. So they have taken into consideration and correctly put it here. Because if you just here, I'll just show you. One is of negative sign, that is minus h1. Then h1 is positive here, so positive sign. Both are coming from the same node, so that is shown here. Then they are connected to a one point, that is you can just see here. To this, what are three things? One is minus h2 is coming, minus h1 is coming, and this g1 is coming. So if you see here, g1 is coming, minus h2 is coming, and minus h1 is coming. So to this point, this, then what is this? This is shown here. It is d is shown here. Then this is nothing but this point, that is. So if you just here, this is initial point, then d is this, e is this, then this point whatever is there, that is here, and then this takeoff point is here, or the point of feedback. Then this is the summing point is also here. So all the things are there, converting a given thing into a converting a block diagram to the signal flow graph. Now, important again, find the number of forward paths. Forward path are two. One here from R, a straight line to C. This is a single forward path, that is G1, G2, G3. And one more is like this, G4. So there are two forward paths. So what will be the formula? P1 delta 1 plus P2 delta 2. That is the formula. Then what are the loops? Loops are three loops. That is minus G2 H1 plus G2 G1 H1 plus G2 G1 H1. Then minus G2 G3 H2 minus G2 G3 H2. This is this. Then to this forward path, that is P2, there are loops which are not touching. Which are those two loops are not touching? All these three loops are not touching to this forward path. So what they have done is 1 minus forward path number 1, loop number 1, loop number 2, and loop number 3 are all taken into consideration. So, but delta 1 is 1. So in case if delta is there, what is delta 2? Delta 2 is this. So what they have done is they have substituted the value and they have got the answer. They substituted and they have got the answer. Is it? Just take down this problem at your leisure. Slowly you take down. Don't get confused. And one thing is, there are so many problems which are there in signal flow graph and this block diagram. You solve those problems, and if you have any doubts, please you can put an image or this in the group or in the classroom that can be solved during the for others benefit. If there are any problems which are not understood, you can just put that images, that I'll solve it and I'll put it in the classroom so that it will help everybody. I hope you understood this problem. Any doubts? Anybody has any other doubts?
No doubt, sir.
Okay, you just take down this problem, but and you can mark these two problems as important for this, note it down. Okay. Is it done? Is it clear? Any doubts? Okay. So with this, the problems on the signal flow graph are done. So with this, I'll conclude the chapter and today's class. In unit number 2, the one part is done, that is block diagram and signal flow graph. There is one more part which is remaining, which will be done later. So next class, the remaining part which was left in chapter number 1, that is of pneumatic system, thermal system, hydraulic system, and AC motor and DC motor, that will be held in the tomorrow's class. So what I'll do is, in tomorrow's class, I'll start with the hydraulic system, then thermal systems, then motors. That I'll be discussing in tomorrow's class. So after discussing of that, the unit number 1 will be over. Then we'll go to the next part of unit number 2. Okay. Is it done? Any doubts are there? If you have any doubts pertaining to signal flow graph, let me know. Anyhow, this PPT, I'll just share it with that modification of that, which part was slightly missed out from my end. I'll just complete that part, and I'll upload this notes into your this Google Classroom that you can refer, and any doubts are there, that later on you can let me know. Is it done? Is it clear? Any doubts?
No, sir. No, sir.
Okay.
No, sir. No, sir.
So with this, what I'll do is I'll conclude today's class. Okay.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.